Okay then.
Is my screen visible to you all?
Yes, ma'am.
Okay. So this is the 60 session on the course maintenance and repair of concrete structure. So first we'll go to the outline, whatever you have studied in the 6 week. The things, this was a smaller week, so you might have studied only two things about compatibility of repair material with substrate, and the next module, in which first topic you might have studied surface preparation methods for concrete and steel. So the first thing is the what are the different volume change mechanism in case of repair material and substrate material. First thing is thermal coefficient of expansion. So if thermal coefficient of expansion of both the repair and substrate material, just a minute. If the thermal coefficient of expansion of repair and substrate materials are different, there are chances of that shear bond between those two materials can be disrupted. Next is the modulus of elasticity. So, if both the substrate and the repair material are of different modulus of elasticity, there are chances that the bond between these two material can fail, and all, or there are chances that one or the other material that cracks before the first material. In this case, mostly if you have a higher modulus, if we see the stress strain curve of can you please mute yourself?
धन्यवाद। हाँ? अरे कैस्टर्ड ऑयल मंगाया था, उसके साथ नारियल ऑयल।
Um, guys, can you please mute yourself? Okay. So in this case, if we have two different material and one have a higher, this is the basic stress strain curve of a concrete system, right? So the elastic region, this region will give us the elastic modulus. So the material which have higher elastic modulus, it will experience more stress values, right? So more will be the stress, higher are the chances of it to be get fail before the lower modulus material. The third thing is creep. So whenever we are applying a repair material, we are assuming that the substrate material, the old material, have already experienced the creep, the service creep, which is have to experience in the whole service life. So when we are using the repair material, it will experience some creep, and because of this creep, there are chances that the shear bond between these two materials will be breaking. Next is the drying shrinkage. So same as creep, drying shrinkage is mostly within a month period. So obviously our substrate material will be older than that. It's so whenever we are applying the repair material, the shear bond between the old material and the new material will be failing. So these are the different volume change mechanism which are repair material and substrate material are facing. So whenever we are using repair materials, what are the basic ingredients of the repair materials are binders. Mostly we are using cement, and in some cases we are using epoxy or something else. Next are the fine aggregates. So fine aggregates, sand, and now they are using RCA also. Recycled concrete aggregates, they are also being used as the fine aggregates and coarse aggregates. So these are the basic materials which we are using for concreting as well as for repair material. Along with these materials, we are using some special fillers like fly ash, silica fumes, or microsilica or something like that. Those are the special fillers. Why special fillers are being used? Because they cover all the pores in our material, make the repair material very fine, and because of that the further deterioration will be avoided. Next are the polymer modifiers. So some chemicals we are adding to our repair material to avoid problems like which we have already talked about: creep, shrinkage. Mostly shrinkage is the major issue. So to avoid these kind of issues, we are using polymer modifiers. And next is the fiber reinforcement. So fiber reinforcement, what they are doing, they are making the bond stronger as well as increasing the tensile strength of our repair material. Okay, anyone have any doubt in this topic? Okay, so yes, you were saying something.
No doubts, ma'am. You can
Okay,
go ahead.
so next thing is the bonding of repair material to existing concrete. So when this is our existing concrete, this is our repair concrete. Two type of failure chances are there. Either they will experience tensile stresses, and this tensile bond will be breaking, or other thing is shear bond, like we have seen because of shrinkage or other cases. This is shear bond between these two type of material will be failing. So to avoid tensile stresses, this kind of surface preparation is required. If we have more surface area, we can avoid tensile stresses between these two materials, and we can increase our tensile bond between the materials, between the substrate and the repair material. How to avoid shear force, sorry, how to make a shear bond stronger is making the surface rougher. So if we have a rough surface, this there will be a mechanical interlocking between these two materials. They will avoid the failure due to shear bond. These are the two type of surface preparation mechanism from. And other thing is how we are measuring this repair and substrate bond strength. So there are four major tests which have been performed. First is slant shear test. uh, this is our substrate material and this is our repair material. So we will apply compressive strength on this new material, and we will check it should not shear at this plane, at this surface, sorry, at the surface there should not be any shear failure. So this is the first test. Second is the direct shear test. In direct shear test, we are applying load in the direction of the bonding. In slant shear test, we are applying at the 45-degree angle. Next is the pull off test. In pull off test, we are taking out the core from the new material, and we have to make sure that it should not take only the repair material. If only the repair material is coming out, that means our bond is not stronger. So whenever we are doing pull off test, it should take out the core from repair as well as substrate material. Next is the splitting tensile method. In splitting tensile method, what we are doing, mostly we will use it will be a circular cylinder, and we are applying load on this plane as well as this plane. And how we are telling it's tensile strength, because as you can see from the arrow, it's mostly compressive strength, right? So the load is applied in this direction, but the material experiences stresses in these directions, so that's why we call it as splitting tensile strength test. Any doubt in this slide? Okay, so this was the first module which you have completed. In second module, you might have seen about the journal surface preparation procedure. First is to first procedure is to using the hammer or any other material, we have to test the rebar locations. We check the rebar locations and map out our complete surface, mapping out our complete surface, checking the rebar location and all other different things. Second is to the undercutting and cutting of the concrete surface. In this method, in this step, we make sure that we are doing the undercutting of rebar as well. All the top surface as well as the rebar undercutting has to be done. In third step, what we are doing, we are cleaning our uh, this is also, sorry, this is undercutting, and this is the uh, other planing the surface. We are planing our surface, and next is the cleaning our surface, cleaning the concrete, and next is the cleaning of rebars. We have to make sure that our rebars are cleansed before we apply our repair material. So these are the different concrete removal methods which you might have studied in the lectures. This is the chipper, normal chipper, which we are using. Some hydraulic methods by using water jets. We are using splitters. What's difference between splitters and these type of material is they are chipping of the partial concrete. In splitters we are removing the complete concrete. And there is another method in which we are using this roller um, cutters to remove the concrete. Other thing are the how we are cleaning the reinforced steel. This is the needle cleaner. These needles are made of metals, and some vibrations are applied on these needles, and they will clean our rebars. Next is the water jets, same water cleaning as we do for concreting. Using the high pressure water, we are cleaning our rebars. And last are the rust removal. These are the chemicals which are applied over the steel surface to remove the rust from the uh, metal surface. So this is what you might have studied in this week. If anybody have any doubt, please let me know. Not, then we will go to the question and answers. Can we go to the question and answer session for today?
Okay, man. So this is the first question. In case of different modulus of elasticity of repair and substrate material, which of the following cases is correct in case of load applied parallel to the interface? So EO is the modulus of elasticity of old material, and En is the elastic of modulus of new material. So load is applied in the parallel direction. So what do you think is the correct option? First is the shear bond is stressed. Shear bond between these two material is stressed. Second is the material with high modulus experiences more stress. Third is material with low modulus experiences more stress. And last is material with low modulus undergoes elastic deformation. What do you think is the correct answer? It's D. Option B and D should be right now.
Okay. Anybody else who want to guess? Okay, right. Option B and D are the correct answer. As we have already talked, the material which will have high modulus, from the stress strain curve itself we can see, sorry, if this is the E of this old, sorry, two material have different elastic modulus. Material having higher elastic modulus will experience more stress. Okay, this point is clear. Last is material with low modulus undergo elastic deformation. Material which have low elastic modulus at a particular strain level, imagine this is the strain level, at a particular strain level, if this material is going like this,
it is going into the plastic deformation area, but this material with low modulus will still be in the elastic region. So we will say material with low modulus undergo elastic deformation. Is this point clear to everyone?
Yes, ma'am.
Okay. So the next question is, if the net tensile stress exceeds the tensile capacity, the repair material will crack. Is it a true statement or a false statement?
True, ma'am.
True, correct. So if the net tensile stress exceeds the tensile capacity of the material, the repair material will crack. I think this is a very simple statement. Everyone is clear with it, right?
Yes.
Sorry. So next question. RC piles of a dry dock in Cochin port are experiencing severe corrosion induced spalling of cover concrete. The following operations are considered during the patch repair process. Coating of rebar with alkaline slurry, which could be an electrical insulator. Connecting sacrificial galvanic anodes to the clean rebars. Removing the cover concrete, undercutting and removing the rust scales on the rebar. Providing additional rebars to account for the lost steel cross section if required. Placing the repair material in the patch region. What should be the sequence of operation? What would be the first step you will do in such case?
Uh, First one will be removing the cover and undercutting, removing the rust scales on rebar.
Okay, fine.
Then providing additional rebar to account for loss cross section.
Okay,
Second,
ready. Right. Next.
connecting the sacrificial galvanized anodes to clean rebars. Third one, and the
Okay.
fourth one should be the first one, coating the rebar with an alkali slurry.
Okay. And the last is the.
And
So let's see if any option matches this. 3, 4, 2, 3, 4, 2 is there. 3, 4, 1, 2, 5 is there. 3, 4, 2, 5 is there. Before connecting any anode, shouldn't we coat the rebar? Or we should use only one method out of these?
sorry,
See, coating the rebar with alkaline slurry, why we are doing this method is basically to provide the alkaline environment to the rebar so that the passive film is formed. And
understood.
if it is becoming an sorry, and if it's sorry, if it's becoming an electrical insulator, even if we are connecting the sacrificial anodes to it, there are chances that anodes won't work, right? Because to make anodes work, we have to, the electrical connection should be there between the old rebars and the new rebars, sorry, in the between the rebars and the anodes. So out of these options, only one thing you can do, either you can apply the alkaline slurry or you can apply the anodes, right?
Even if the anodes are connected, we can apply the slurry on top of it, right?
You can apply slurry, but there are chances that your
As a
connection will,
secondary,
sorry, huh?
as a secondary, what do you call secondary option? That is, if the system one fails, we'll have a system two in place. If
Yeah,
we're
system.
connecting that,
Yeah, but if you are providing an electrical insulator over the rebar, there are the anodes won't work, right? They need electrical connection from rebars to anodes. If you are providing insulator over the rebars, the anodes won't work properly. The connection is, see that you apply the tie bar over the rebar. If the tie bar is in the tie between rebar and tie bar, if there is any slurry, so the potential difference won't be there. The anodes won't work properly. Yeah, you can apply some
And this is
coating over the rebar, that is fine. But if you are providing an insulator over the rebar, then anodes won't work properly. So either you can apply the slurry thing or you can apply the anodes thing. Okay. So we'll get to the next question. Which of the following is not an example of polymer modifiers? Latex, acrylics, microsilica, or epoxy emulsion?
epoxy emulsion, ma'am.
Epoxy emulsion. Sure. Polymer modifiers are mostly chemicals only. So these latex, acrylics, epoxy emulsion, they all will comes under polymer modifier. But if you see the microsilica, it is SCM. So the microsilica is mostly the filler material, not polymer modifier. So answer is microsilica. Epoxy emulsion is a type of polymer modifier only.
Yeah, polymer.
Okay.
But, ma'am, this
Yeah.
is not polymer modifier, right, ma'am? Epoxy emulsion is kind of a paint.
Epoxy emulsion, but we are adding epoxy emulsion also. We are adding epoxy as a binder also in case of repair material when we are doing only the patch repair. In some cases, we will add epoxy emulsions. Hello, is it okay? Can we go to next question?
Yes, ma'am.
Okay. Sealing of the mixing water to prevent evaporation and supplying of additional water are considered as two approaches to cure concrete. Which of the following are not exclusively representing the former approach? Means the first approach, spraying of curing compounds, placing polyethylene film on concrete surface, ponding and fogging, wet burlap cloth or sack. Uh, First, former approach is how to prevent evaporation. We have to prevent evaporation. So, which of the following methods are not representing preventing evaporation from the surface? Last is very simple method. We are using sack or any wet cloth we are applying over the surface so that the water from the concrete is not evaporating, right? Ponding.
Ma'am, I believe
Huh?
placing polythene film on concrete surface should be an exclusive method.
But question is not exclusive. You're saying placing polythene is not an exclusive method for evaporation, right?
Yes, ma'am.
Okay. Anybody else who want to guess the answer?
C, ponding and fogging.
Ponding and fogging. Okay.
Ma'am, that is basically supplying additional water, right?
Yeah. That is the see. A question is which is not an exclusive representation of first method, preventing evaporation.
Okay, okay, okay.
So these ponding we are using additional water. Same way we for using wet clothes, we are supplying additional water. So I think you missed the question. It is not representing the first thing. Okay.
Ma'am, in the first option, it is spraying of curing compounds. Means what are
Yeah.
the compound we are generally spraying for?
What are the curing compound you are generally using that you want to ask?
Yeah, 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 yeah.
I really don't know about the chemicals which they are using as the curing compounds. There are different
Yeah,
type of compounds they are using. Some powder they are mixing with water and spraying over the concrete surface. Exact chemicals I also don't know about them, but it's mostly some chemicals they are adding into the water. Some chemicals they are directly spraying if they are in liquid form. Something like that only.
okay, okay, got it.
Actually, in industries and all, whenever we are doing flooring, we'll have a requirement of using the floor immediately. So at that times, what we use that we just spray this compound. It is like polyamides, some
Okay.
kind of polyamides. We just spray it on top of the surface, and it will do prevent any sort of evaporation that is tend to bound to happen.
Okay.
And this in that way it will do the curing. That is curing compound. Polyamides is a chemical.
Polyamides. Okay, okay. Thank you.
Okay. So next question is, before applying any repair material, we have to make sure that the substrate is completely dry, completely wet, or it should be saturated, or the substrate need not to be any preparation.
It should be saturated, surface dry.
Yes, ma'am. C option, C.
Right answer, saturated. If it's completely dry, there are chances that the repair material will not bond properly with the substrate material. And in case if it's completely wet, what can be the loss? Any idea?
What, ma'am?
Bleeding might happen, ma'am.
Yeah, we will have additional water into our repair material and there are chances of bleeding. Somebody was asking something. No?
No, ma'am, actually, I not heard about the question. What you asked.
Okay.
It's bit.
So I was asking if our substrate is completely wet, what is the loss? Why completely wet surface is not a good substrate material before applying and repair? So
Yes,
if
ma'am.
it's
It will lead
completely,
to bleeding problem.
yeah. So this question is clear to everyone, right? Next question. Why undercutting of rebars and removal of loose material during surface preparation is must? Because it's provide a good mechanical grip, remove chances of corrosion, increases strength, or help in cleaning rebars.
Provides good mechanical grip, ma'am. That is the only answer.
Yeah. Anybody else who think any other answer is correct?
It's A only.
Okay. Next question. Match the following. Methods of
Ma'am,
placing.
sorry, there was a D option was also ticked in it.
Oh, no, no, sorry. I think I did it wrong. Answer A is the only correct answer. Yeah. Match the following. Different method of placing and nature of repair material. Dry packing, forming and pumping, grout, pre-placed aggregate, and short crating. Sorry. What do you think should be the nature of repair concrete in case of dry packing? should be a flowable mix, or it should be a pumpable grout with gap graded aggregate, or it should be a dry mix, or should be a well graded aggregate with binder. First option, dry packing.
Option C might be relatively dry mix.
Okay. Next is form and pump. We have to use the form work and then pump the concrete into it.
Global mix, man.
Flowable mix, correct. Next is grouted pre-placed aggregate. In grouted pre-placed aggregate, what we are doing, if this imagine if this column we have to fill, so we will pre-place all the aggregates, and then we will pump the uh, concrete into it. So that is grouted pre-placed aggregate. So in this kind
So,
of
ma'am, third option should be like a flowable mix. I was wrong.
grouted pre-placed aggregate, you think should be a flowable mix. Okay. Then what should be the forming and pumping? See,
And shotcreting is a gap graded aggregate plus pumpable grout.
see, if we are talking about mix, what we actually say about mix. Mix means we will have aggregates plus cement and plus water, right?
It can
So
also mean M sand and sorry, sand and cement also, no?
normally we won't say it as mix. We will say it as a yeah mortar mix. Okay, fine. Yeah, it's concrete slash mortar. Okay, see the answers. First, C, dry packing will have a dry mix. Second, A, form and pump will have a flowable mix only. You were correct first time. Third is B, grouted pre-placed aggregate will have a gap graded aggregate plus pumpable grout. Why is like that? Because when we are saying that we are placing our aggregates before and then adding concrete to it, in this case if we are first we will add aggregates itself, right? And it should be gap graded because we have to fill concrete into it, we have to fill our mortar mix into it, sorry. So if we are adding the well graded aggregates in such case, the mortar will not go into the small pores. So that's why in grouted pre-placed aggregates we will have gap graded aggregates, and then we will pump the grout into it. Grout is mainly our mortar mix. And shotcreting, how we are doing shotcreting?
We are pressure pumping it
By
pressurely.
pressure, right? So in pressure thing, we should have well graded aggregates and binder only.
And pumpability should also be there now.
Pumpability should be there. See, flowable mix should be, I think it will be for every case, right? Sorry, pumpable mix should be for every case. But if we go by these option only, so for short creating, the well graded aggregates and binder will be the most suitable case. Why? We have two type of short creating. Uh, I think you guys have not read about it as of now. In one case, we are adding, one is the sorry, dry shotcreting, another is the wet shotcreting. In wet we are using the complete mix and doing the shotcreting. In dry mixing we have two nozzles. Through one nozzle water is being pumped, and other nozzle the dry mix will be pumped. So in this case the dry mix should have a well graded aggregates and binders, and the uh, other pump will have the water in it. So that's why this short grading, we are saying that well graded aggregate per binder is the correct option. Is it okay? Or you still have a doubt about it?
No, no. Yes, ma'am. I was not aware of this dry greeting.
Okay. Anybody else who have doubt in this thing? This question?
No, it's clear.
Okay. So this is the next question. What are the advantages of pulsating water jet over other type of water jet for concrete removal? This is an open question for discussion. So you guys can tell according to you what are the advantages of pulsating water jet. You can take 2 to 3 minutes and can tell me that. Anybody who want to tell any advantage of this type of water jet over other type? You know different type of water jets, right? One is the plain water jet, other is the abrasive water jet, and third is the pulsating water jet. In plain water jet, it is like a normal pipe we are using at home. Simple water jet will be there. We are simple water will be uh, used pumped out. And second is the abrasive water jet. In abrasive water jet, what we are using some aggregates or some stone kinds of things, so that along with water, so when water with these abrasive material strike on the concrete surface, it will remove the concrete. Third is the pulsating water jet. In pulsating water jet, what we are doing, we are using the high pressure system. So what do you think can be the advantages of this kind of water jet over the other two types?
And we can say that when you are using the pulsating water jet, it can easily clean the surface before edge repair
Okay,
as
it is
compared to
the
the other two methods.
okay, fine. One advantage. Anybody else who want to give any other advantage?
What I think is that by using pulsating water jet, we can even cut off these loose concrete particles also, because abrasive
Yeah,
and all
abrasive.
can
Hmm.
just do an overcoat only can be removed. But I believe by pulsating we can even cut the loose concrete also.
Okay, correct. Other advantage. See, by changing our velocity, we can also change the type of cutting we want, the depth of cutting we want. I think somebody have posted it. More efficient, less manual labor. Okay, that is also correct answer. See, if we can increase our speed, we can decrease the time of work it requires, and so it will be more efficient. Fine. Any other person who want to guess? If we can change our velocity, we can even increase or decrease the depth of cutting we want. Like if a surface is there and we want the depth of cutting at one point is different than the other point, we can change our velocity of the pulsating jet and have a good kind of concrete removal, right? That can also be an answer.
And water jet can only cut the ones which are deteriorated, right? It
Yeah.
cannot do a fresh, doesn't it?
No, no, not for fresh, only for deteriorating.
Not aware of it. That's why, ma'am.
Yeah. Okay. So So these are the main advantage which were given in your lecture, that it will give deeper removal of concrete than continuous water jet, and depth of concrete removal increases with decrease in transversing velocity. So these are the main schematics of different type of water jet. I think you all have already understood why pulsating water jet is more advantageous than other two type of water jet. So that's all for today. Thank you. If you guys have any doubt, you can ask me now. If you have any doubt in assignments or anything. Okay, if there are no doubts, then we can close the class for today, right?
Yes, ma'am. Thank you.
Okay. Thank you, everyone.